How long would it take us to get to Pluto? Once upon a time in 1930, there was a little 11-year-old girl called Venetia. One morning, as she was eating breakfast with her grandfather, it struck her to suggest calling the newly discovered planet Pluto. And that's exactly what happened. Pluto is a really cool place in outer space. It's much smaller than Earth's moon, and it has a nice heart-shaped glacier that's the size of Texas and Oklahoma combined. It's an icy dwarf planet that is very, very far away from us. It's so cold that nothing can live on it. It's about half the size of the United States, and it's so far away from the sun that it takes over 30 years for it to go around the sun once. Pluto has blue skies, and it has spinning moons that look like they're dancing in the sky. There are also really tall mountains like the ones here on Earth, and when it snows, the snow is red. Have you ever wondered how long it would take us to get to Pluto? The answer lies within the vastness of space and the technology we have available to us. From an average distance of 3.7 billion miles or 5.9 billion kilometers, Pluto is 39 astronomical units away from the Sun. 1 astronomical unit is the distance from the Sun to the Earth. From this distance, it takes sunlight 5.5 hours to travel from the Sun to Pluto. That means if you take 5 hours and a half to get to work and back, the Sun takes the same amount of time to get to Pluto, which is really far away. It's really dark on Pluto, but the Sun is still there. It's not nearly as bright as the Sun here on Earth. It's about 300 times brighter than the full moon, so it's kind of like a really bright twilight here on Earth. There is a moment each day here on Earth when it is the same brightness as midday on Pluto. That's called Pluto time. Can you find out when that happens near you? As we said, it is estimated that if we were to travel to Pluto at the speed of light, it would take us about 5.5 hours. However, due to the limitations of current technology and the vastness of space, it would take much longer than this, potentially hundreds of years, to reach Pluto. The journey to Pluto would be one of the longest journeys ever attempted by any human. Some of the challenges we would face include severely limited fuel, supplies, and food, and a very long, dark journey through space. If you're interested in undertaking an interstellar journey, you'd first need to secure a space-worthy vehicle and enough fuel and supplies to make the trip. From there, the journey to Pluto would be long and arduous, not to mention it would take an incredible amount of patience and determination. So how long would it take to get to Pluto from Earth? It all depends on the technology, resources, and preparation we have available to us. But one thing is certain. It would be a long and difficult journey that would require a great deal of dedication and courage. The answer to this question is both simple and yet incredibly complicated. It is simple in that it is almost impossible for us to make it to Pluto in a human lifetime. But it is complicated in that the journey to this distant and mysterious realm of our solar system entails a great deal of planning, physics, and engineering. Unlike other planets that are located within a few light years of Earth, Pluto is located an incredible 4.67 billion miles away. With the technology and knowledge that we have today, such a feat of space travel would require an immense amount of understanding and experience in rocketry, engineering, and astrophysics. Yet our journey to Pluto and its moons, Charon, Nix, and Hydra, is one that captures the imaginations of space enthusiasts, scientists, and dreamers alike. As a dwarf planet, Pluto remains a wonderful subject of exploration and discovery. With its perplexing outer atmosphere and its unknown details, Pluto continues to be a source of fascination and wonder. In this video, we will explore all that we know about Pluto, the possibilities of the journey to the dwarf planet, and the wonders of what we may discover. If you're still watching, like our video and click on subscribe to get informed about a new topic every day. And this is where enters the New Horizons mission. In 2006, the United States launched the New Horizons mission that made history as the first spacecraft to ever venture to the planet Pluto and beyond. After a 9-year journey, the spacecraft reached its destination on July 14, 2015. On that day, we were given a glimpse of the distant world that exists beyond our solar system. What we saw was remarkable, providing us with an unprecedented view of Pluto and its moons. For over a decade, the New Horizons mission has been studying the far reaches of our solar system and providing us with more information on the planet Pluto and its moons. It has helped us to better understand the origins of the solar system and to draw new connections between the planets, moons, and asteroids. By studying the surface of Pluto, the mission has uncovered remarkable evidence of geological activity and has shed light on the dwarf planet's composition and environment. New Horizons took a picture of the surface of the planet Pluto, and it's much younger than scientists thought it would be. On the surface, there is a mountain range that is almost as tall as 11,000 feet, which is really tall. Scientists think that this mountain range is really young, only about 100 million years old. Nobody knows why it is so young. This could prompt astronomers and geologists to consider potential sources of energy which may fuel geological movement on other icy planets. In mid-July of 2015, images were sent back from the spacecraft New Horizons, which showed a huge plain of land on Pluto that did not have any craters. Because of this, geologists believe it is a relatively new terrain, so they have informally named it Sputnik Venetia. They're still trying to figure out what caused the land to form in this way. In July of 2015, the world was captivated by the news of the historic flyby of Pluto by the New Horizons spacecraft from NASA. After traveling for nearly a decade and covering 4.8 billion miles, the spacecraft was able to capture stunning images of the dwarf planet. However, it was not until after the flyby that the world learned of an even more remarkable feat: the discovery of 4 moons around Pluto by the New Horizons team just days before the spacecraft's closest approach. This fortuitous discovery was truly a stroke of luck for the entire mission. The moons named Kerberos, Styx, Nix, and Hydra are small, no bigger than 90 miles in diameter, and would have been easily overlooked had the team not taken a closer look at the Pluto system. Even more remarkable is that this discovery was made with a relatively small telescope based on Earth. Without the discovery of these moons, New Horizons would have had to navigate through the Pluto system with no knowledge of the moon's positions. This increases the chances that the spacecraft could have been damaged or destroyed by a collision. Scientists had to make sure that these moons didn't hurt the spacecraft, so they had to be careful. The fact that the moons were discovered early is a testament to the dedication of the New Horizons mission team and the importance of continued exploration of our solar system. With the successful flyby of Pluto, we were able to gain a unique and unprecedented look into the still largely mysterious region of the outer solar system. And because of the discovery of the 4 moons, this flyby was able to be completed without risk of damage or destruction to the spacecraft. The discovery of the moons of Pluto shows us the importance of looking closely and paying attention to the details, even when studying a system that is billions of miles away. We are fortunate that the moons were found early, allowing for New Horizons to move through Pluto's system without obstruction. Without this stroke of luck, we may have never seen such incredible images of Pluto and its moons. The New Horizons spacecraft has made several discoveries, including evidence of a past ocean on Charon, a moon of Pluto, and strange hills on Pluto made of water ice and frozen nitrogen. In 2018, one study suggested that beneath the surface of Pluto could be an asphalt layer, and some scientists have also suggested that there could be enough ingredients on the surface of Pluto for life to exist, despite it being so far from the Sun. So what did we learn from the New Horizons mission? The mission has also provided us with insights into the temperature and atmosphere of the dwarf planet, helping us to better understand the conditions that exist on its surface. We have also gained a better understanding of the structure and activity of its moons, including the presence of ice volcanoes on Charon and the mysterious deposits of nitrogen ice on Nix. The mission has also answered many questions about the origins of Pluto and its moons, providing us with evidence that these exotic bodies were formed from the same primordial disk of gas and dust that birthed our solar system. What future does Pluto have in space exploration? The journey to Pluto and beyond has opened up a world of possibilities for further exploration and research. As the data and images from the New Horizons mission continue to be analyzed, there are sure to be more discoveries in the coming years and decades. Who knows what mysteries of the universe we may uncover next? For now, let us rejoice in the success of this remarkable mission and the amazing discoveries it has made. The New Horizons mission has shown us that anything is possible and that the journey to discovery is an ongoing, evolving one, especially since there is an upcoming one in the near future. Persephone, a comprehensive 30.7-year mission to both orbit within the Pluto system and encounter a few Keplerian belt objects. Persephone is a really cool mission to go to Pluto. We are aiming for Persephone to launch by 2031 and to perform a flyby of Jupiter in 2032. In 2050, we are looking forward to a flyby of a Kuiper belt object, and then in 2058, it will reach Pluto to begin a 3-year orbit. It's possible that it could then journey on to another KBO in 2069. A rocket would launch with a special spaceship on board, and it would take about 27 years to get to Pluto. That's like your entire childhood. But it would be worth it because once it gets there, it would help us learn more about Pluto and something called KBOs. KBOs are special things that are in space, and Persephone would be able to fly by them and take pictures. So it would be a really great mission to witness. Exploring the Pluto system is a difficult challenge. It is a long way away, and the speed of the mission must be slowed down, resulting in a long cruise time and a more expensive mission plan. In order to operate for the 30-plus year cruise, more advanced power sources than the current radioisotope thermoelectric generators, RTGs, are required to complete the mission. Why do we need to get back to Pluto if it is so difficult, you may ask? The New Horizons mission gave evidence that Pluto is unexpectedly geologically active despite how far it is from the Sun, and scientists now suspect that it contains an underground ocean and that it is not as lifeless as we may have seemed. This could mean that there is life on Pluto, but this can only be confirmed by further study. To understand why Pluto is active and if it contains liquid water, researchers propose sending a spacecraft into orbit to measure its gravity signature. The only way to gain a better understanding of this phenomena is to orbit the object multiple times, closely observing how its gravitational pull influences the spacecraft. How long would it take us to go to Proxima Centauri? That of one day reaching out and touching the stars is a relatively recent desire of our species. We can perhaps date its appearance to 1838, the date that is when the German astronomer Friedrich Bessel first succeeded in determining the distance to a star and clarifying the extent of the problem we faced. A dream, we said. But with recent advances in technological development, it seems that dream is slowly becoming a reality, hand in hand with our growing awareness of the limited resources and environmental problems we face here on Earth. Indeed, stars are far, far too far away, but there you go. If there were an exoplanet with some Earth-like qualities within a radius of a few light years, not 100 or 1,000 as is the norm, then yes, this could work. It could be a bit like the Moon, which served as a first step, a spur to get us to the other planets. We could start seeing interstellar space as a sea sprinkled with islands rather than the current unreachable void. But what's going on there among you who are listening? I think I could hear someone tapping on the monitor and protesting. But yes, there is this planet. We've been assured of it since 2016. Well done. This is exactly where I wanted to take you, awakening and measuring your attention. It's true we have an extrasolar planet very close to us, discovered in 2016, but confirmed absolutely only recently. And that's incredibly lucky since the average distance from Earth of the other 5,000 extrasolar planets is about 300 light years. A stroke of double luck, since the planet orbits the closest star to Earth, namely Proxima Centauri. A fortune that many are now realizing. So even NASA has apparently decided to go and have a look there by the end of this century, with a project that is finding strong resistance in certain scientific circles, but which the American Space Agency believes it will be able to launch by 2069. A date obviously not coincidental, remembering what happened exactly 100 years earlier. That would indeed be an exhilarating feat, would it not? But where then does anyone's skepticism come from? Well, the immensity of the distance that separates us from Proxima is scary anyway. How can you blame them? Moreover, it is enough to look a little closer at the destination of this trip to immediately realize that going to the moon was like climbing the first step of a staircase that has more than 100 million steps. 100 million. Yes, because Proxima Centauri is exactly 100 million times farther than the Moon. Alpha Centauri is a system composed of 3 stars. Alpha Centauri A, officially Rigel Kentaurus, Alpha Centauri B, officially Ptolemy, and Alpha Centauri C, officially Proxima Centauri. Alpha Centauri A and B form a binary pair of Sun-like stars revolving around their common center of gravity. Proxima Centauri is a red dwarf revolving around the 2 main ones at a distance of about 0.2 light-years, and is only 4.25 light-years away from us, or about 40 trillion kilometers. The extrasolar planet we are talking about, called Proxima b, revolves around Proxima at a distance of about 0.049 astronomical units, more than 20 times closer than Earth is to the Sun, but still within the habitability zone. Compared to some other depths of the cosmos, we are basically talking about our own backyard. Yet a trip to Proxima with current technology would take about 78,000 years. An enormous amount of time, calculated based on the maximum speed reached by our fastest probe, New Horizons, which is 59,000 kilometers per hour. If, on the other hand, we wanted to reach Proxima with a journey of the reasonable duration of 20 years, a spacecraft would have to travel at an average speed, including acceleration and deceleration, of more than 300 million kilometers per hour, or 28% of the speed of light. Quite a difference, wouldn't you say? In short, NASA will henceforth have the difficult task of finding a faster way and more effective technology to reach at least the stars closest to us. It would require the development of a propulsion system that would reach at least 10% of the speed of light to reach the Alpha Centauri system in an acceptable time. The main difficulty lies in storing the fuel load necessary to enable the spacecraft to be able to accelerate steadily to the expected speed threshold. Despite the seemingly insurmountable difficulties, several interstellar ship concepts have been proposed in the past decades. An early example dates back to the studies and experiments conducted in America in the 1960s as part of the Orion project. Basically, the idea was to harness the shockwave produced by the sequential explosion of many small nuclear bombs to accelerate a spacecraft to high speed. The project was originally designed to put large masses into orbit or to enable human missions to Mars, but someone realized its potential for interstellar travel as well. In the original version, the Orion was to eject nuclear fission bombs in rapid succession, which, detonating just behind the vehicle, would give it a substantial boost through the impact of the shockwave thus generated on a special shield, capable of absorbing the shock without damage. A more powerful version with fusion bombs was later suggested by British physicist Freeman Dyson, but it was soon overtaken by technological advances and the changing political climate. However, this concept, which would solve several of the problems discussed above, remains suggestive and could be applied to launching small probes to the stars. In those same years, American physicist Robert Bussard proposed an original way to solve the mass problem by avoiding carrying the necessary propellant. Thus was born the concept of the interstellar ramjet, a vehicle capable of collecting the hydrogen present between the stars as it traveled and harnessing it in a nuclear fusion engine. But apart from the problems presented by making the actual engine, collecting interstellar hydrogen would be anything but simple. In fact, assuming an average density of 1 atom per cubic centimeter to collect 1 kilogram of hydrogen at 1/10 the speed of light would require a huge funnel with a mouth over 5,000 kilometers in diameter, and the matter collected would still be negligible compared to the needs of propulsion. This is why interstellar ramjets, in their various proposed versions, are not considered physically feasible. In the 1970s, the British Interplanetary Society conducted a detailed study of a variant of the Orion design called Daedalus, under the leadership of British aerospace engineer Alan Bond. It is perhaps the most realistic interstellar ship design conceived to date. Instead of nuclear bombs, the Daedalus was to make use of a series of micro-explosions produced by nuclear fusion of small deuterium and helium-3 tablets. The fully automated, 2-stage spacecraft would have been able to reach 0.1 c, 10% of the speed of light, with a mass at the departure of 50,000 tons, or 93% of which was propellant. This would have enabled it to reach Proxima in just over 30 years, then transmit the information gathered during the flyover back to Earth. Another promising proposal is the Star-Wisp laser sails, where the problems of mass and heat are solved by eliminating the engine, replaced by the pressure exerted by a beam of radiation directed onto a very light sail. However, the problem of energy and also that of travel time must be addressed with highly innovative solutions. Since the original idea was formulated in the first half of the 1980s, the interstellar sail concept has undergone several reworkings and improvements, mainly to limit the energy requirements of the voyage and to make its operation more plausible. In any case, the main elements of the system would consist of a very powerful laser or microwave transmitter, probably placed in space, a giant lens used to concentrate the radiation into an extremely collimated beam even at a very great distance, and the actual interstellar sail, capable of intercepting the radiation and being significantly accelerated by the pressure thus exerted. And when we say sail, we don't mean a racing spinnaker, but of something at least 6 kilometers in diameter and weighing only 30 grams. Accelerated to 0.2 C in just 2 weeks, Star Wisp could reach the Alpha Centauri system in as little as 21 years. Another possible solution is that of antimatter propulsion. We know that 1 gram of antimatter, when converted into energy, generates an immense amount, about 70 times that produced by nuclear fusion, and 4 billion times the energy produced by burning oil. Such an engine would enable us to reach about 40% of the speed of light, and the duration of a trip to Alpha Centauri would be reduced to just over a decade. However, little antimatter exists in nature now, and it is not easily captured. It is therefore necessary to produce it, which is done in infinitesimal quantities in large particle accelerators. Making engines specifically for space exploration, however, would require several grams of it. This sounds like nothing, but it is a vastly greater amount that has been synthesized to date. Just think that an accelerator would have to run its antimatter factory for about 1 billion years to produce a single gram of antimatter. Even if we imagine technological innovations such that this immense time would be cut down, the conventional energy required to produce a couple of grams of antiprotons per year would be equivalent to a total energy consumption corresponding to about 50 billion watts, equal to the power output of all US nuclear power plants. So this is currently our situation. We want to go and see the planet Proxima b, but we don't know how yet. Our technology is practically still in its infancy, although it is progressing rapidly. No one can predict what humans will be able to do by the fateful date of 2069. But if development proceeds at the current rate, along with many new problems to be solved, we will also have greatly increased our capabilities in precisely those fields crucial to interstellar travel. In the beginning, the missions directed to the stars will probably be conducted with intelligent robotic probes, miniaturized beyond any currently conceivable limits, capable of traveling at 0.1 C. But one need only extrapolate a little to the extraordinary progress being made in the fields of biotechnology, genetic and molecular engineering, embryonic development, and cell physiology to realize that even with simple probes such as those, humans themselves could rapidly propagate around the galaxy, as proposed by physicist Frank J. Tipler and described by Arthur C. Clarke in the fascinating novel The Songs of the Far Earth. In practice, this would involve the creation of so-called von Neumann probes, i.e. intelligent automation that, upon arriving at their destination, would be able to construct from available raw materials copies of themselves and habitats for eventual living beings, including humans, synthesized in situ from the information contained in the genetic code and instructions for the generation and development of embryos. Having successfully initiated the colonization of a world, von Neumann's probes could then build new interstellar spaceships and automation, destined to take the flight to other star systems to repeat the feat. Of course, we are talking about small probes. Interstellar travel with humans on board, and NASA will have to take this into account, would be enormously more complex, involving mass and energy scales thousands to millions of times larger. What can be conceived with current knowledge points us back to the idea of interstellar arcs, giant ecologically self-sustaining habitats capable of roaming the stars for thousands of years, as countless generations of humans, animals, and plants follow one another within them. These arcs could be built on the model of the giant space colonies studied by physicist Gerald O'Neill in the 1970s, and then launched into interstellar space even at modest speeds of less than 0.01 C. But it is difficult to imagine under what conditions and for what reasons human beings should undertake a journey knowing already for certain that they would never reach their destination. Probably only the progressive uninhabitability of our own and other solar system planets colonized in the meantime. could induce many to that extreme choice. The discourse would change drastically if it became possible to significantly extend human life or slow down metabolic processes during travel, while being able to reach, with the large spaceships required, at least speeds between 0.1 and 0.3 c. But for this to materialize, it will probably have to take several more centuries, unless physics still holds some incredible surprises in store for us. How then will NASA make good on its promises? May it have an ace hidden up its sleeve? Don't worry, we'll just have to wait until 2069 to find out.